So problem number 1 says a jar contains 4 black buttons and 5 brown buttons. If 4 buttons are picked at random, what's the probability that all of them are black? So the numerator in a probability function needs to represent favorable outcomes. The denominator needs to represent total outcomes. So if you'll maybe write that at the top of your paper and let that be your focus, favorable out of total. So this question says, I want to know the probability that all of them are black. So what's my favorable? Black. Okay. So of all of the buttons, 4 of them are black. So favorable would be 4, total black, choosing the 4 that they asked me about. Now, where does the 5C0 come from? Those are the 5 brown, choosing none of them if I get all 4 black. Okay, so that's favorable. Total, 9 buttons, choosing 4 black. Okay? Now, the other way to do this problem, you cannot do this with a binomial distribution at all because it is not binomial. It violates the independence assumption, which means that as I draw a button, I don't replace it, and so the probability changes from one event to another. And so if I start out with 4/9, 4 black buttons out of 9 total, and I take it out and I don't replace it, that leaves me with 3 out of 8, then 2 out of 7, then 1 out of 6. And that will get you the same answer. So 2 different options for doing that problem. Keep in mind, your focus has got to be favorable out of total. Okay? All right, so now for number 2. I have 3 different ways to do number 2. Okay. So a 6-sided die is rolled 10 times. What is the probability that the die will show an even number exactly 8 times? Okay. What's n in this scenario? 10. It's 10. N is 10. Right? What probability am I looking for? The probability that even number, how many times? 8 times. So x is 8. Well, if I'm rolling a die that's fair, half of them are odd and half of them are even, so the probability of success is 50%. So, total, choosing 8. 10 total, choosing 8. 0.5 to the 8th power, 0.5 to the 2nd power. So now let's talk about where these 2 0.5s come from. What does this 0.5, the first 0.5, represent? So this would really be P, which we're calling the probability of success. What about this 0.5? That's failure. This we call Q. Okay, the first exponent is always what you're choosing. So I'm choosing 8. That's why that exponent is 8. The second exponent, whatever it is, has to add up to the total number n. So that's one way to do it. Another way to do it is as a binomial PDF. And the reason you can do a PDF is because it says exactly 8 times. So it fits all the binomial assumptions, which Tyler called out earlier, but it says exactly 8 times, which is a PDF. All right, so that's another way to do it. And the command in the calculator is NPX. All right, here's another way that someone else came up with. Favorable, 10C8 out of total, 2 to the 10th. Just another way to think about it. All of those ways will get you at the same answer. Just getting better, maybe? Okay. All right. Number 3. 2 different ways to do number 3. A basketball player has a 50% chance of making each free throw. So that 50% represents what? P, probability of success. What is the probability that the player makes at most, underline those words, at most, 6 out of 8 free throws. Okay. If you're going to do it in the calculator as a binomial distribution, you have to use CDF because it says at most. Exactly is for PDF. Any other inequality is for CDF. So that's why we have what's in blue. All right, so let's look at the other way. It says at most 6 out of 8. Yeah. All right. So can anybody explain to me why I did a complement on this one? So it says at most 6 out of 8. So if I was going to do this the long way, at most 6 means none of them, 1 of them, 2 of them, 3, 4, 5, or 6. How many different calculations is that? That's 7 different calculations. Or I could do 7 and 8 and subtract them from 1 because that's the complement. Much easier to do it this way if you're going to do it using a combination than it is to do 0 through 6 and add those together, which you certainly could do it that way. It's just 7 calculations like this first one versus the 2. Caitlin? Yes, N is the total number of trials. P is probability of success, and Q is probability of failure, which is just the complement from 1.
Can you remind me how to find
So go second bars and scroll. You'll see all your distributions there. And y'all, a little trick. If you will look on the bottom left of your calculator, there should be a button that says catalog. You have to hit the shift key. So like second something should be catalog. You see it? What's the button? 0? Okay, so second 0 gets you to the catalog. That's an alphabetical listing of all the things that your calculator will do. If you hit the alpha key, you can go straight to the letter that you're looking for. So let's just try it. Let's say you wanted to get to the binomial distribution. So go alpha and then find the key that's got the B on top of it. It'll take you to all of the B things that your calculator will do, and then you can go to binomial distributions. Shortcut around that, okay? That's what that catalog is for. All right, moving right along. 2 different ways to do number 4 as well. What is the probability that the die will show an even number at most 11 times? Okay, if I do it by hand the long way, and I roll the die 13 times, it says at most 11, I've got to add 0 and 1 and 2 and 3 and 4 and so forth, all the way up to 11. Or I can do the complement. This is by hand. I can do the complement of 12 and 13. Or I can go straight to CDF, NPX. Definitely easier. Again, if you guys have come up with a different way of doing it, please let me know so I can add it to this list. Yes. Okay, so if they, bless you, if they don't give you a probability up front, and you know that it's like true, false, cracked screen or not a cracked screen, making the shot, not making the shot, that's going to be 50-50. It's an implied 50-50 if they don't give it to you otherwise. Okay? All right, number 5. So I broke this down for somebody in first period, I think, to make it look a little bit different. And so on number 5, it says, a technician is launching fireworks near the end of a show. Of the remaining 12 fireworks, 7 are blue and 5 are red. So these would be the blue, and these would be the red. Okay, I'll explain that in just a second. Remind me, okay? And so it says that if she launches 6 of them in a random